So, again, many of you have already seen Kathy talk to you about these linear patterns, and you also have that instruction sheet. But I wanted to give you this video to catch up those who weren't here or those who just may need a little more help with it. So what we're going to do is talk about what a linear pattern is and how to recognize it, and then be able to write a rule that will allow you to find any number in a linear pattern. So the first thing we want to talk about is what is a linear pattern and how do you know? So looking at your worksheet, the very first one is this pattern, 6, 9, 12, 15. We know that this is a linear pattern because if we take the first number, the second number, third number, fourth number, etc., and this 3 dots means that they go on in that same pattern infinitely, forever, and we subtract them, then we're going to get what's called a common difference. So common difference. That simply means that you're going to get the same number every time you subtract. Two consecutive numbers Remember, consecutive means one right after the other. Difference always means that you're subtracting, right? And common means the same. So, common difference. Hugely important that you understand that term. Okay? So, what we will do is we'll simply take the second number minus the first number, the third number minus the second number, the fourth number minus the third number. Now remember, you always have to subtract the second one from the first one from the second one, and etc. in order. So our second number here is 9 minus our first number, and 9, which is 6, which gives us a difference of 3. Then 12 minus 9 gives us 3. Then 15 minus 12 also gives us 3. So you can see here that no matter which numbers I subtracted, as long as I did them in order, what happens is you got the same difference every time, a common difference of 3. So that tells us that this is indeed a linear pattern. If you got another number, say you subtracted, you got 3, 4, 5 or something, then you know that you don't have a linear pattern. These differences have to be the same in order for it to be linear. If it is linear, we can then write a rule to find any number in the pattern. And the way you're going to find that rule is you're going to have A times N plus or minus B. Now I know that looks a little confusing, but it's really easy to find. The A and the N and the B are just numbers, letters that are standing in for numbers. And this letter N is always going to stay the same. It always stays N. That's the number of the term. So it's talking about the order of the numbers. So for example, let's go back. This was the first one. That means N is 1. This is the second one. That means N is 2. Third one means N is 3, etc. So we could go on and on and on and on infinitely, right? So what we're going to do is we're going to talk about what these letters mean. And A is simply that number that you found that's the common difference. And it always goes right in front of your N in your pattern. Remember that when you have a number right next to a letter, that indicates multiplication. So in the one we just did, we got a common difference of 3. And we don't have to write 3 times N. We can just simply write 3N. Okay, now what we want to do is we want to find B. Well, B is easy to find using your first digit, the first number in the sequence, and your A. Okay, so here's how you do it. To find B, first, if A is positive, because remember we have negative and positive numbers. So if A is positive, subtract A from B, from the first term to get B. Okay? Second, if A is negative, because you can subtract a small number, a big number minus a small number and get a negative number. If A is negative, then you're going to add A to the first term to get B. And whatever sign it has is going to determine here whether or not you have a plus or a minus. If it's positive, it's plus. If it's a negative, then it's a minus. Okay? So subtract if it's positive, add it if it's negative. You're doing the opposite. Okay? So let's just go back to that pattern and work through those steps. So we had 6, 9, 12, 15, etc. So we take 9 minus 6 gives us 3, 12 minus 9 gives us 3, 15 minus 12 gives us 3. So we see that we do indeed have a common difference. So this is a linear pattern. So our A in this case is 3. So first part is easy. Just put our 3 in front of our N. Okay. Now what we have to do is find the second part. Remember, because it's AN plus or minus B. So we have to find this B part. And again, in this case, our A is positive 3, right? So what we're going to do is we're going to take 6 and simply subtract that number. 6 minus 3, because again, 6 is our first term. That's where I got the 6. Gives us 3. And because it's a positive 3, it'll simply be 3n plus 3. And that's as easy as it can get, guys. All right, let's look at a few more of these. So here, for example, number 9, we have 15, 13, 11, 9. So let's... Okay, so 15, 13, 11, 9, ... So this is a case where the pattern is decreasing. It's going down. The numbers are getting smaller. So watch what happens. 13 minus 15 doesn't give us 2, but it gives us negative 2. And we know that it was going to be negative because the numbers are going down. Negative 2 literally means down 2. So then we'll do 11 minus 13, which is negative 2. Again, down 2. We'll do 9 minus 11, again, negative 2. So that is our A. In other words, our common difference. Always identify your A, your common difference. It's really important that you see that because that's the thing that tells you that it is indeed a linear pattern. Then we'll put that negative 2 in front of our N. And now what we need to do is I need to find the B part of it. Remember, because it's A times N plus or minus our B. And all I need to do that is, since it's minus 2, I'm going to take the first term and add 2. I know it's a little strange to use looks like you're using the wrong one, but what you're doing is compensating for that negative 2. And 15 plus 2 gives you 17. And since it's a positive 17, that means we put plus 17 here. Okay? And there is our pattern. That way we can find any number. If I want the 100th number, the 20th number, the 30th number, I can use that pattern to find it. Okay? Let's look at one more just to make sure that everybody's understanding what's going on. Say, for example, let's see. Oh, let's do number 4. It's got 1, 7, 13, 19. One, 7, 13, 19, ... First, we need to determine if it's linear. 7 minus 1 gives us 6. 13 minus 7 gives us 6. 19 minus 13 gives us 6. So we have an A, or a common difference, of 6. So we do know that it is indeed linear. So we're going to put that 6 in front of our n. Now I need to decide plus or minus our b. Since my a is positive, what I'm going to do is I'm going to subtract it from our first number. Okay? So it's 1 minus 6. And 1 minus 6 gives us negative 5. So it's 6n minus 5. Because this was negative, that needs to be a minus between the two. And there's my pattern. Okay? The hardest part of this is remembering that if this is positive, you need to subtract it. If it were negative, you would have to add it. So do make sure you memorize that fact. That's the key to making this work. Let me rewrite that 6. It's really ugly, huh? There you go. So 6n minus 5. Okay. So now that we know what a pattern looks like, let's use a pattern to be able to find the next term in a sequence. Okay? So we'll just use the pattern that we have. It doesn't matter. All of them will work the same. Let's say we want to find the 20th number in the sequence. Now I know, because it says 20th, that this is an n number. 20th tells you which number it is, where it is. So all I'm going to do is simply replace n with that number. Again, that's your first step. Then simplify. And remember, simplify, when we talked about order of operations, simplify is that math word that means do the math. Follow the order of operations. So it's 6 times 20 minus 5. And we have to do the multiplication first. So 6 times 20 is 120. Minus 5 gives me 115. So I know that the 20th number in this sequence is 115. If I want the 100th number, I could find that just as easily. But instead of 20, what I'll do is, in place of the n, I'll put 100 minus 5. 6 times 100 is 600. Minus 5 gives me 595. So that's the 100th number in this sequence. And you can do that no matter what pattern you have. And again, the way you'll know that it's the n is it's the 100th, or the 20th, or the 1st, or the 3rd. Look for those keys that tell you that it's a number that's in order. So that tells you that that's the number that you need to put in place of n. And notice that I use a parentheses here, a bracket here, because a number in front of a bracket means to multiply. If you prefer, you could write it as 6 times 20, 6 times 100. Both of those things mean exactly the same thing. Okay? Now, so you'll do that paper, all of those patterns and all of those rules, and then at the very bottom, the last few questions ask you to find your own sequence. So just make up your own sequence. Okay? And it can literally be anything. So let's say I put negative 5n minus 2. That's a linear pattern. Now let's find the numbers that belong to it. The first one, the second one, the third one, and the fourth one. Again, I just made these up. They can be any numbers you want. I wouldn't make them too big because it makes everything get really big fast. But you can use any numbers you want. I happen to pick negative ones because I just wanted to shake things up a little bit. So our first number, so we'll replace the n with 1. So negative 5 times 1 minus 2. Negative 5 times 1 is negative 5 minus 2. Those two numbers are negative, so negative 7 is our first number. So our first number in the pattern is negative 7. Now let's do the second number. Negative 5 times 2 minus 2. Again, we always have to do the multiplication first. So negative 5 times 2 is negative 10 minus 2 gives us negative 12. So negative 12. Alert on my phone.
Oh, mine's silence. That's why I didn't get it.
Ah.
It's Nima.
Yeah. Level 4.
Yeah.
Scared the crap out of me. Sorry, I didn't mean for you to hear the alert on my phone, but I thought I hit pause. So you can make up your own pattern. It can be anything you want it to be. And then just continue it out about 4 numbers. So we'll do the third number. Negative 5 times 3 minus 2. Again, you have to do the multiplication first. And then combine those together. Get you negative 17. And then you can continue on. Let's look at one that's not quite so complicated. So again, any numbers you want to. 3n plus 15. It makes no difference what pattern. Again, those last ones, you're just going to make up your own pattern. So we have the first number, the second number, the third number, and the fourth number. Try to do at least 4 numbers. So first, we'll just put 1 in place of our n. So 3 times 1 plus 15. Where we have to do the multiplication first. So that's 3 times 1, which is 3. Plus 15 gives you 18. So 18 is our first number. Then the next number is 2. So 3 times 2 plus 15. You have to do the multiplication first. So 6 plus 15. Add together to give you 21. So that's the next number in the sequence. Then 3 times 2 plus 15. 3 times 3, we're doing the third number. Gives us 9 plus 15. Okay. Which is 24, which will be our next number. All right, so they just keep continuing in that same exact pattern. Okay. And the way you can know that they're the same, that they're really working, is that if you subtract them, you should be getting that common difference that is the number in front of your n. Okay? So, give them a shot. If you have any trouble with them, please don't hesitate to contact either myself or Kathy. We'll be happy to help you.